Yeah, if you want to present, I'll keep an eye on it.
Okay, well, welcome everybody. My name's Itzel from the 3C Run group in Ventura. Today we're going to have our carbon reduction through building electrification part 1 from our all electric design and construction series. We have Jennifer and Andy here from Imbalance Green Consulting. Next.
Okay. Sorry.
Yeah, no worries. So we ask that everybody make sure they are on mute throughout the duration of the course. If you would like to verbally participate, please raise your hand in the participant section and we will call on you to unmute yourself. And we encourage everybody to ask questions in the chat as well. Next slide, please. A little bit about 3C Run for new people that are joining in. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. We work on improving energy efficiency in our region by offering free programs and services to building professionals and households. 3C Run is funded by ratepayer dollars that we collect through our public good charge on our utility bills. Next slide. We currently have 3 programs. I'll just talk very briefly about them. The first one being the Energy Code Connect program, where we offer industry trainings, regional forums, and Title 24 consultation service called the Energy Code Coach to help building professionals navigate the California Energy Code and green building requirements. We have a phone line. I believe that is the old phone number, but we will post the new phone number at the end. We'll have a slide for that. Our next program is the Building Performance Training Program, where we offer trainings on technical and soft skills related to building science principles and systems for high performance building. And our last program is our Home Energy Savings Program, which serves households that are historically underserved with free and discounted home energy upgrades. And with that being said, I'll hand it over to Andy to get us started today. Thanks.
Great. Thanks, everyone. Welcome. We're so glad you're here. And I'm just going to do some introductions in order to get us rolling and make sure that we are getting the credit we need. So we're doing twofold purpose here that over these 5 parts of the series is that we are providing AIA learning units, but we're also providing the ZNCD, Zero Net Carbon Design learning units that are required for California licensed architects. And so at the end of the whole series, we'll provide you a certificate in order that reflects the that the training is compliant. And we take attendance. So if you are in a room with multiple people, make sure that that you send around a sign-in sheet. If you're just logging on in your own station, and we'll take care of that automatically. And if you're an AIA member and you registered with your AIA number, that you'll be able to get that will be done automatically as well. Next, please. So this is a 5-part series. You need 5 units of credit for licensure. So we did line this up. We did a series maybe a year and a half ago, and for overview of zero net carbon design. And so this one's specifically targeted for electrification. Today is the overview about carbon reduction through building electrification. And then the rest of them are specific to electrification systems. Next one in January will be heat pumps for heating and cooling. Then we'll go into domestic hot water, ventilation, and heat recovery ventilation, all tied to the energy code and has some differences when we do all electric equipment. And then the wrap up will be appliances and energy storage systems. It talks a little bit on the PVs, but we've learned a lot about PVs already, so energy storage is where we're at. So to jump in, here's the learning objectives that are required for the AIA in terms of what we'll be providing. And the important part here is that we'll send you the slides. So you don't have to worry about taking a lot of crazy notes from this, and they'll have references and links as well. So we'll send you the slides as a PDF after each of the sessions. It's also, I didn't say initially, but the zero net carbon design, the state requires that the course be live. So you can always go back and watch these as videos, but in order to get the credit, you do need to be here in person, as it were. Okay, and then our agenda for today, we're going to spend some time kind of talking about the clean energy goals overall. And some of this has to do with the narrative, the buy-in of the general public to be able to understand why we're going in this all-electric decision as a state and, you know, as a planet. Then we'll talk about some of the macro issues about the electric grid and transportation, and then finish with some examples of all electric zero net carbon design kinds of buildings. And Jennifer Rennick is an architect and a certified energy analyst, and she'll be your main presenter throughout all 5 parts of the series. I'm also an architect and a LEED accredited professional, and more tuned in on the California Green Building Code. And for other components of the series, we'll have other folks circling in to support Jennifer as she goes through the courses. So if you have questions, we'll be monitoring the chat. We will get you out of here by 1 o'clock. That being said, if you have residual questions, lingering questions, we will stay on the phone longer, but you can jump off because we are trying to make sure that we fit this within your lunch hour. Any questions or anything I missed so far? All right, we'll hand it over. Jennifer.
Sandy, hi everybody. I'm glad you could make it. Like Andy said, today we wanted to give a big picture overview of how, you know, us as architects, how our buildings kind of fit into where California's going, and how we transport ourselves as part of how we get around our in between our buildings and through our communities. And Andy's going to touch on the transportation part of it, because that is that a lot of that falls under Cal Green. And then I'll take a look at the sort of the building sections, like Andy said, and kind of these big picture goals. And before we get started on this, I would like to do a vocabulary review. So something that I'm finding as an architect working with the other architects, but also just with the general public who are our clients, is a lot of times not everyone is on the same page with what certain words mean. And for the architects and how it's kind of phrased for architecture licensure, we talk about ZNCD now, as opposed to just zero net energy or zero net carbon. We're talking about zero net carbon design as being both operational carbon, which would be the energy component of how much energy your building uses, and the embodied carbon, which is related to the materials and the construction of a building. And both of those have a metric that often people just refer to as CO2, and they say carbon for short, but it's not really CO2, it's CO2 equivalent. And so you'll see there's a small lowercase e associated with the CO2 as you read through the literature. And maybe as you're talking to people, it's important to remember that sometimes the discussions are derailed because people say, well, why are we so worried about carbon dioxide? It's already in the air. And really what we're saying is there's a metric that we use to kind of talk about this in general, and we've equated it to something we've called CO2E, or CO2 equivalent, or carbon, as we refer to in the design trades. And then there is global warming potential, which is using that metric of CO2e, and we use carbon, the real carbon dioxide has a baseline of 1. And then everything is compared to that baseline of 1. So the higher the GWP, the higher the global warming potential, the more impact it has on our environment. And that's that GWP is also a common metric used for refrigerants. And these are the refrigerants we use in all our heat pumps and our heating and cooling systems, a lot of our cars. And so to decarbonize means we're looking at ways to eliminate or reduce those CO2 equivalent emissions. And when we speak of fossil fuels, we're specifically talking about our oil, our gasoline, diesel, natural gas, propane, etc. But we also talk about our non-combustion, meaning we didn't burn this fuel, but it could be methane that could be burned. But in this case, when it's non-combustion or just high GWP materials, we're specifically referring to our refrigerants and often the methane that's associated with the dairy industry, for example, or methane that's released in landfills. For example, it's not being burnt like our fossil fuels, but it nonetheless contributes to greenhouse gases. And then those greenhouse gases, what the California Air Quality or Air Resources Board is looking at, California as a whole, is carbon dioxide, the real carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, et cetera, et cetera. And these are the top greenhouse gases. And then when we talk about clean energy, specifically, we're usually referring to electricity, and that is produced without greenhouse gas emissions. And then when we talk about, or you hear green fuels or clean fuels, a lot of times we're talking about hydrogen fuel cells. And if those hydrogen fuel cells are made from solar energy, they're considered green. But if you have to use other fossil fuel sources to create the hydrogen in the first place, it's not so clean. They sometimes refer to it as blue or not clean hydrogen. So that just kind of give you an idea. And then these three organizations, NOAA, Department of Energy, EIA, Energy Information Administration on the national level, you'll see those acronyms a lot in the literature, just a reminder of what we're talking about. And then it's specific to California, we're going to refer to the California Air Resources Board, or CARB, and the California Energy Commission, and then the California Independent Systems Operator, which is the group that's responsible for our energy grid in California. Okay, so a bunch of new words for some folks, but at least maybe this gives you a little bit of background and maybe helps when you're talking to a layperson and trying to translate between what you might be reading and learning about and then talking to your clients. And then kind of this big picture of how, as an architect, or how do your clients fit into this big picture of carbon reduction, both operational and embodied carbon is, I mean, the bottom line is humans in everything we do in our buildings is somehow tied into carbon emissions. So when we talk about carbon reduction and decarbonizing, we're really talking about everything. And we're talking about how we transport our water, as that takes energy, which has carbon impact, how we produce our food, and the shelters we build for ourselves. We have also, under that food category, we're talking about agriculture and forestry, like the wood that's used. And how do we transport our wood? How do we transport our food? All of those have an impact when we start to look at embodied carbon reduction. And all types of energy and fuels go into this mix. But we need that energy to power our buildings, and we need that energy to power our transportation. So when we talk about decarbonization, it can include specifically looking at the energy our buildings take, and it can also look at the manufacturing materials, how those materials are manufactured, because that takes energy to manufacture them. And a lot of our buildings use refrigerants, and they use all sorts of electricity as well. In California, a lot of our existing building stock uses natural gas directly and burns it for heating our hot water and our spaces. So the decarbonization equation includes everything, and the state of California is basically looking at everything. And then as architects, we kind of focus on our buildings, of course, and a little bit related to our transportation, because we're asking our buildings to basically be a source of energy for our electric cars. In California and in the United States, the biggest source or the main driver of those CO2 related greenhouse gas emissions is the burning of fossil fuels. And the CO2 emissions, that is the largest contributor to climate change. And as we were just, discussing on the previous slide, we burn fossil fuels for our transportation, our industrial processes. We use it to generate a lot of our electricity in the state. And then, of course, we use it for all the equipment that's used, or most of the equipment that's used in our agriculture and forest industry. And then, of course, we use fossil fuels for space heating and water heating in our buildings. So California's identified the primary sectors responsible for the majority of the greenhouse gases. And this chart here shows the way California's kind of categorized that out. And it's just interesting to note that transportation is at the top of the list, so to speak, where 39% of our greenhouse gases in California is attributed to transportation. Hence, why transportation is being picked up in our Cal Green Code, and why California has a big push to move towards electric vehicles as a way to start to decarbonize our transportation sector. I think it's also interesting to note that California has started to take a look at how our greenhouse emissions by category and by their scoping plan of how they're addressing all this, where we've as a whole decreased our CO2 equivalent emissions, and where some of these emissions have increased and where some stay steady. And it's good to note that the transportation and our industrial sector and our electric power, how we create our electricity, has decreased. However, during that same time period, as we move towards heat pumps for heating and cooling, move away from burning natural gas, move towards more and more heat pumps that use refrigerants, our GWP related to refrigerants has been increasing. So along with all of this, at the same time, there's regulation where the equipment has to use lower and lower GWP refrigerants. And so you'll start to see that equipment roll out next year.
And Jennifer, do you go,
Yeah.
I mean, I remember like R410A used to be like the good GWP, the lower global warming potential of the refrigerants. But now, well, there's that won't even be legal anymore. And do you touch on that in session 2, the refrigerants?
Yes.
A little bit? Yeah. Okay.
Yeah,
Great.
we do touch on that when we move into the other sections, but that's right, what Andy said. So like the R410A was the good one because a lot of the refrigerants we used were
They're
like
even worse.
6,000 GWP of CO2 equivalent. And then the 410A refrigerant, which is really common, that's around just over 2,000. But the new regulation that comes into effect this January for some of the equipment, and then some more of it will come into effect the following year. We're saying the refrigerants all have to clock in under 750 GWP. And
So if
like
you wanna get-
CO2
good.
is actually the real CO2, not the equivalent, but the CO2 can be used as a refrigerant, and it's being used more and more as a refrigerant itself. And that clocks in at GWP of 1. So the technology is changing, and the manufacturers are responding to that. So the market's changing. At the same time, California is putting these regulations in place and helping to drive that market that way. And California is not the only place. Europe is doing this, and other countries as well as California as a state.
Great. Thank you. Just wanted the sneak preview on that one, because it comes
Yeah.
up fast. Okay.
Right.
Thank you.
Yeah, and then when we take a look, it's kind of that same, the same information, but like aggregated out more. Then we're starting to see that our buildings and construction as a whole account for about 25% of the greenhouse gas emissions in California. And that's partly because a portion of the industrial processes go towards building our buildings, like our cement manufacturing or concrete, for example. And there's general fuel use in that. That's also part of it. The transportation sector, yes, we move ourselves around in and around our buildings. And so planning how our communities are planned, how do we move ourselves around buildings, but it's also the transportation of all the materials we need in our buildings. And then of course, there's a component that's associated with the refrigerants we use in our building. And then we have the building sector itself, and that's about 10%, where residential accounts for roughly 6.5% and the commercial sector for 3.5%. And because of that residential accounting for about 6.5%, we decided this first go around on this series is going to have a more residential focus when we get into these other courses, but the principles will be the same. And then we're going to have a follow-up series starting in March. Well, we're having a follow-up series. I'm forgetting the dates, but a follow-up series that's going to hit more on the commercial scale on these same impacts. And then Project 2030, for example, estimates that buildings actually account for 42% of global greenhouse gas emissions when they take into more account of the fact that so many of our materials are manufactured out of state and out of country. Okay, so any questions, put them in the chat. That idea was to try and give you a big picture of how we and buildings fit into what California as a whole is doing to tackle greenhouse gas emissions, and how we as a whole fit into that picture of California for decarbonization, for reducing both embodied and operational carbon. And big piece of this too is that our buildings are reliant on the electric grid. So how we make our electricity is just as important as where our electricity comes from. Well, just as important as how much electricity do our buildings need to use. So a little bit more vocabulary, because when you start to read, dig in, if you choose to, dig into what the state of California is talking about and looking at, you're probably going to hear folks talk about reliability. And specifically, they're talking a lot of times about the power distribution system and the transmission lines. And they're saying, is that transmission of energy steady and continuous? That's the reliability component. And then adequacy. They're saying, do we have enough resource capacity, enough electricity to meet the demand that all our people and buildings are requesting? And soon all our electric cars will be calling for. Do we have enough resiliency in that? Can we safely and efficiently power down and power off our electric grid or portions of it to keep our public safe and to prevent wildfires? And then we have climate action goals. And the idea behind these goals is, can we quickly implement zero net carbon electricity production? And just one piece of that is how California does monitor and track which areas of California have the highest threat to fire. And those are the places in this map that are in red, where really they're talking about improving the resiliency and the ability to turn off portions of the grid in order to stop wildfires. And then we'll need another resource of energy for a lot of those folks when the grid gets turned off. And that's where battery storage can come into play. So California, the good news is California's electric generation is becoming cleaner. So right now, only 31% of our electricity is generated from the direct burning of natural gas. And that's a huge improvement for where it used to be, where most of our electricity came from burning natural gas. And right now, non-hydroelectric renewables, so mostly wind and solar, is providing approximately 38% of that total mix, and that is increasing as we speak. So that's the good news. California has definitely reached the halfway point, or beyond the halfway point, of having non-fossil fuel electricity generation. And part of meeting that, if you want to understand it more, there's the 2035 and beyond report that specifically was addressing upgrading the electric grid with new advanced conductors without the need to build new electric overhead lines in California. And the reason I mention this, and this is a big deal, is because I've heard a talking point that California will never reach these goals because their electric grid is so old and it's not able to transmit enough electricity. And then you have a lot of other groups that want to stop new lines from being built in their either neighborhood or certain swaths of state-owned land, etc. And so what this is saying is that actually with technology and just reworking these lines, we have the ability to increase the capacity to meet this demand. One of the key concepts for how to understand our electric grid and how that works with solar and wind energy, and understanding that our buildings and people have a need for electricity 24/7. But the sun only shines during the day, and wind luckily usually is blowing when the sun isn't shining. So there's some synergy with wind and solar together. But nonetheless, we have in our state a need for electricity when our PV panels, when our sun isn't able to meet that demand. And right now, we do two things. One, we fire up our power plants that burn fossil fuel that make electricity. And two, we pull energy from battery storage. And the state is moving towards more and more battery storage, where we have solar generation that exceeds the demand. And that's kind of the part of the chart where the yellow is the solar energy and the demand is the green line. And so that extra energy is stored in batteries. But we have these huge areas where the sun doesn't, or times where the sun doesn't shine, and we need to burn fossil fuels to still meet that need, or have other energy resources available, like small hydro and geothermal, etc., nuclear. And this is just an example, and it's close to us. It's up in King City, and these natural gas peaker plants provide a rapid response of electricity, and they help meet that electric demand that is, helps meet a peak that's typically between 4 p.m. and 9 p.m., but it also provides energy throughout the night when our solar energy can't meet that demand. So the idea in California is to less and less depend on burning fossil fuel throughout the day or throughout the night. And instead, we're talking about replacing that need with large solar and wind power, and then store that energy in batteries. And this out at Edwards Air Force Base, it was just completed last year out in Curtin County. It's one of the largest single solar plus battery storage facilities in the United States right now. And this plant's going a long way to helping California have a clean energy grid. In the meantime, as you know from our building codes, we still, like residential's required to have solar, and our new energy code says our commercial buildings, certain ones will also have solar. So California still continues to have distributed energy generation in addition to the power plant size of electricity. And this chart here shows kind of the cumulative, the bar together, the yellow plus the blue is the cumulative impact of how much solar has been installed. And this chart gives you an idea, and this is from what California Energy and Transportation Plan has put out there to say, hey, this is what we're going to have to do in terms of battery storage by the year 2035 and the year 2045 in order to have enough battery storage capacity to meet the rapid expansion of electricity needed when our cars are all electric, or more and more, or a combination of electric and fuel. That's kind of I think that was a lot to kind of for a lot of people, that's a lot of information, and not everyone's familiar with how California is moving in that direction. Feel free to put a question in the chat, and Andy will answer it or stop me to answer it. Okay. One other thing to just keep in mind is California also is looking at what we can do for hydrogen. And there are some demonstration projects, like this one was with Caltech out in Pasadena in combination with Bloom Energy and SoCal Gas. And they're saying, well, maybe it's not a good use of our natural gas to burn it, when we could take excess solar energy and take that natural gas and convert it to hydrogen and use and create the hydrogen when we have excess solar. And then the experiment and what they're starting to do is blending the hydrogen back into the natural gas network. And it's overall, they're able to do some carbon capture because they're not burning a portion of that fossil fuel, but also they can have their system still operate and reduce the carbon footprint of the existing natural gas infrastructure by blending hydrogen into it. So just kind of FYI, this is the kind of demonstration projects and some of the thinking going on in California, as in addition to just adding solar and power and batteries. And then the other thing that's happening in the transportation industry is that H2 or hydrogen fuel cells are being created that can be and successfully being used in the shipping industry, both land shipping, but also ocean shipping. And in case you get a chance, you could go up to San Francisco and actually take a ferry ride on one of the ferries that is powered by a zero emissions hydrogen fuel cell. So they use a combination of hydrogen fuel cell and lithium ion batteries and power up the ferry. So kind of summarize it, California's plan for grid stability and expansion as California moves to a clean energy transition is buildings are going to be increasingly decarbonized as we look at how we build our buildings and how do we build our buildings more energy efficiently, where California is looking at that industrial sector and looking at clean electricity and clean fuels such as green hydrogen, and then the transportation sector, where we're going to have multiple choices coming up in the next year or two for zero emissions and plug-in capable cars, and also transportation like shipping transportation that can be powered by green hydrogen. Okay, so with that, I'm going to let Andy get into the actual transportation part of it that specifically would be of interest to the architects and the planners because of Cal Green and the new requirements that have come into play.
Thanks, Jennifer. I always appreciate the overview because it does remind us that the decisions and conversations that we're having even 5 years ago about electrification, that there was a reasonable argument. What are we doing if we're using fossil fuels to make electricity in the first place? But to see a path where there's a lot of clarity in the direction and we can see it actually being effective, then we can help our clients see that electrification is effective and well thought through. So to jump in a little bit about the transportation, and I think it's interesting that as architects, we used to have to think about people's cars other than where to put them because people would go to gas stations, but now they're trying to charge them. And so now all of our buildings need to have that charging infrastructure. So I'm just going to go through some of the highlights here about what we see in that direction, and just make sure that everybody knows what triggers they need to be looking for in terms of vehicle charging. So one, just quickly, we're having a huge investment in electric vehicles across the country. And, you know, policies will change depending on administrations, but no matter what, we have an industry that is solidly rolling out electric vehicles, and a market demand for it. And then when we see it in California, it is the fastest growing electrification sector. It takes a whole lot of electricity to do it. And so we have all these public charging stations, and then of course private ones as well. Interesting. I look forward to that bi-directional EV charging, because we've got all these batteries in our car. Wouldn't it be great if those batteries in that, like, especially that 4 to 9 peak hours, if when we get home, if we could run our buildings, our homes off of the car batteries, then we're just that much more resilient and solving that problem of the duck curve. So within California and the California Green Building Code, these are kind of the sections to be thinking about. We have different types of charging and then different applications. So there are 3 types of EV. The first is this EV capable, which is the lowest level of effort, but it basically, you put in a conduit and make sure it has a space to an electrical panel and to a place where you could put a box. The next one is EV ready. And so it's wired and has a receptacle, but it's not an actual piece of charging equipment. So you could plug into it, but it's not level 2 or above. And then the last one is an EV charging station, level 2. And so when you physically look at these, level 1 is this kind of plug-in cord that any of us could have in our garage. And then level 2 is what is required in that charging station by the Green Building Code, the 40 amp receptacle or charging station. And then level 3 is a fast charger. Those are awesome, but they are not required by code. They're allowed and they'll meet that requirement, but they aren't required for any of the installations in this case. And so kind of just running through the different types briefly, the single family is that lowest threshold where you need to be EV capable. So you just have to have a conduit and a space for a receptacle, but they didn't want you to invest in actually putting in copper if the resident wasn't going to have an electric vehicle anyway, so they didn't want that abandoned asset. And then for multifamily hotels, motels, they kind of figure out how many spaces you have and 10% of total spaces. And that was last year, or this year, just 6 months ago. But as of July 1, there was like a whole new intervening code cycle. It had a whole lot about embodied carbon, and then this big jump in electric vehicle charging requirements. So now in multifamily and hotels, motels, you have to have 40% of the parking spaces with a low power level 2 EV charging receptacles. That's huge. And then 10% of those, 10% of the total needs to be an actual level 2 EV charger. So one's kind of a low power receptacle. And so for non-residential, similar structure, there's a table, you have so many, and just kind of keeping in mind that how many are EV capable, and then the actual EV charging spaces within that. And it says at least one level 2 electric vehicle system shall be provided. And that's because, as you'll see on the next slide, they also added as part of the intervening code cycle that you can do a little bit of a mix and match, because they're recognizing that the market is evolving pretty quickly. So if you put in a fast charger, that's equal to 5 of the level 2s. Or if you put in the low level power charger, that's equal to half. That's the 20 amp option. Or there's even a power allocation method. I haven't used that yet. So there's some formulas that, again, gives you some options there. Okay.
Oh, real quick question, Andy. Just the question was just a reminder, level 2 low power versus level 2 regular, and it's amperage.
Correct. So, and I might have put it on the next slide. I can't remember now if I took that out or not. I guess not, but yes, correct. So a regular level 2 is 40 amps and a low power is 20 amps. Good question.
So it takes longer with the 20 amp circuit, but
right, but
most
you might be able to fit
homes
it in
have a
your
20
electrical
amp
panel.
circuit.
Right.
Yeah.
Right. Yeah, there's some pretty cool. Yeah, happy to chat more about kind of what are the implications for, especially in a residential setting. And then even in the multifamily setting, they want you to like tie it into the electrical panel for the each individual unit. So that's how that goes. And then just the medium and heavy duty charging. So at the in the regular code cycle, they said, hey, we got to be ready to charge our trucks. And so grocery stores and retail and warehouses had to have enough electrical capacity to be able to add charging stations. And then in the intervening code cycle, they added the manufacturing and office buildings. So we're getting ready.
Right. And then Andy, there's another little quick question, where are the alternatives listed? And so it's all in Cal Green code. Everything Andy's showing you is in the Cal Green code, and we could help you find whatever you need actually through the Code Coach service.
Right.
And we'll stay on the call to answer some questions too.
Right. Right. Yes. The 3C REN is also provides, in addition to education, Code Coach on the energy code and Cal Green, and we'll highlight that at the end of the presentation. So, and it looks like Todd is weighing in too. So thank you. Appreciate that.
Yeah. And then Buddy has a question. How does that count? Yeah. Right. Those are some of the questions actually we've been. Yeah. Go.
Yeah. I don't know, Todd. I'll have to look at that. I think.
Yeah. And then there's that little. Yeah. It depends on the equipment. Like we're later on their presentation. I can't remember if it's 4 or 5. I guess the last one with the appliances. We do hit a little bit on the chargers, and there's different creative things you can do with certain splitters and, yes. Contact Andy.
Yeah, exactly. So,
and you'll
so I just wanted to kind of give a quick highlight. We do have full presentations on Cal Green, but again, just as architects, and we're thinking about that zero net carbon world, is that we need to be at least meeting California Green Building Code, but we might want to be getting ahead of the curve as well, because that's just going to be increasing as we go. And again, market demand and a clean energy grid warrants that interest.
Yeah.
And back to Jennifer to finish out with some examples.
Okay, so this little section here, what I wanted to show you was just some of the projects that have been recognized by either ASHRAE or the International Living Futures Institute and other organizations. And so you can learn more about these projects and you'll get a copy of the slides. But I wanted to just highlight what some of these things are also looking like visually when we talk about how to have enough distributed solar on the building, for example, to meet the electrical needs of it. And so, that picture shows that for an elementary school. So this kind of the basic concept of our buildings is that we're for zero net carbon design. We want to choose materials with low embodied carbon in the first place. And so just kind of an FYI that a lot of it is wood or materials that you can grow. And it typically means finding better alternatives for steel and concrete that is a lower embodied version of concrete. That's kind of big picture right now where we are with the embodied carbon, just high level. And then when it comes to the operational energy, really, we're looking at how much on-site energy can we use, and then can we plug into a decarbonized electric grid. And then we want to design our buildings for energy efficiency in the first place. And when we choose our appliances, we want to choose appliances for space heating, water heating. And by appliances, I also mean like, how do you dry your clothes? Those kinds of things. We want to, and our refrigerators, how do we choose ones that have low and very little need for refrigerants? And that's kind of the big buckets of things to address in our buildings. This was an ASHRAE award for elementary school, and it is the largest net zero verified education project in the US. It has a very robust rooftop photovoltaic system and a very large battery storage system. And in 1 year, that the solar panel system is expected to offset the CO2 emissions equivalent to over 600,000 pounds of coal burned. So that's a big deal in Wisconsin because of how they get their electricity in the first place. So that's a really neat example. And this one I thought was a great example because it just is showing that you can take all these same principles and apply it to existing structures. And in this case, because they were able to use or design a building that fits within an older city, and they chose materials that were able to reduce their carbon footprint of the embodied carbon by 25%. And then they were able to purchase carbon credits after that. And they use PV system that's located on a nearby building because they weren't able to put everything here. So the combination of this building is zero net carbon, zero net energy building. And so it's a great example of what is possible, even within like historic districts. And then in California, leading by example, I think it's good to know that the California Air Resources Board itself, in their big campus down in Riverside, California, they want to make sure that the facility itself was leading and showing all of us that these buildings can be designed to meet our Cal Green Tier 2 standards and be a zero net energy building. And there's, a lot of the buildings that achieve this, they do put PVs on the roof, but they also incorporate, which is super nice in sunny California, covered parking canopy that produces both the electricity and provides for the electrical vehicle charging at the same time. And then this little building I thought was really a nice one, a different state. What I also liked about this is it showed an example of what you could do even for small commercial projects, but it's also the same scale as you would see on a residential project. So it has, for example, 13.5 kilowatt battery storage. That's a small battery storage system, and that would be a typical size you might see on a residence. And then this one was also ILFI certified for zero carbon and zero energy. And then, like so many of the other ones, when we talk about zero net carbon, they're purchasing carbon credits to help offset the embodied carbon that went into the project. So California's pathway to carbon neutrality just a reminder, every 3 years, California Title 24 is updated. We started out with this in the 1970s, and California is still on track to continue this, and by 2045 to be 100% carbon-free electric generation. So big picture goals for for Title 24, the building sector, and usually I think of the energy sector, is that the building code is still going to encourage heat pump technology for space heating and water heating. They're going to continue to establish the electric ready requirements for single family homes, but expand that coming up in 2025 to other building occupancies. And they're under the new code are going to continue to expand the PV systems and battery storage standards. But good news for residential construction, there is not a lot of change. So you don't have to worry about that for the new code coming up in about a year. But the other stuff will just continue to expand the application of these to decarbonize. And so our all electric or nearly all electric buildings, new construction is pretty straightforward. We're going to be looking at, new construction. You can get, for example, this multi-story senior living facility in San Jose we worked on, variable refrigerant flow heat pumps for space heating and cooling. Newer models are going to be coming out with low global warming potential for the refrigerants, solar PV system on board. The building was designed to be energy efficient from the get-go. But existing buildings, we're going to be looking for incremental opportunities, because as the existing buildings age, we really need to be looking at our HVAC replacement, appliance replacement, and then adding solar and batteries and envelope improvements to those buildings. And then also when we talk about our existing communities as a whole, the real big approach here is to decarbonize the grid itself and reduce the need for natural gas as burning natural gas for our electric generation, because it won't be possible to change every existing building right away. So it's going to be an incremental approach. Okay, and with that, I'm going to hand it back to Andy, and then we'll be done here and let you all go. And we'll stay on for questions.
Yeah, we're just wrapping up here. We know folks need to jump off, but again, the climate action plan here, we have a roadmap, and just to remind folks and your clients, this is not the tree hugger fringe, it's just how we build now. And we are seeing that, just like LED lighting used to be exceptional. Why would you do anything different now? So that's what we're seeing with the electrification. And finally, just want to make sure that that you have this resource, Title 24 Energy Code or Cal Green. It's totally free. It's open to designers, engineers, clients, developers, builders, building departments, and we'll just help answer questions. And that comes directly to our team of certified energy analysts to take care of it. Again, we'll stick around to answer questions. We'll let Itzel close us out, and be sure that you register for every class. If you just registered for one, that won't do it for you. You got to get a new link each time. If you joined late, if you joined, we have your information, but if you're in a group, be sure to let Itzel know so that we're keeping track of all that, and you will get your certificates at the very end of the full 5 series, depending on how many you were able to attend. Itzel, any last remarks, and then we'll stick around for questions.
Awesome. Just really quickly, thank you both for a great presentation. And if you have any questions regarding AIA learning units or your certificate of completion, feel free to email me. I'll add my email on the chat. And you'll be getting the slides and the recording sent to you too, so you can reference anything Andy and Jennifer talked today. And upcoming courses, a sneak peek for next year. The rest of the series is also there. I'll put the link in the chat so y'all can look at that later. But with that being said, thank you. Thank you for everything. Thank you for joining, and I'll hand it back to Jennifer and Andy for questions.
Great, thank you so much. So with that, we'll stop sharing screen. Again, you'll get all of the slides, and if you have a question, you can raise your hand, or you're welcome to just unmute and turn on your camera. And if you have feedback, any experiences that you want to share, we're happy to stick around, but or otherwise, you know, get on with your work days. We get it. So any
Oh yeah,
questions?
Charles shared in the chat the picture from the project that it's working on, that we're helping, but
Yeah, that's
he's
sweet.
the designer. That RM is that you all are doing.
Is that the what building is that? Is that
That's the dispatch center. So
that's the dispatch center? Wow, it's beautiful. Yeah, that's a real zero net energy and zero net carbon, right? You guys had to do the whole analysis on the embodied carbon of the concrete and steel.
hopefully in a year we can say it's certified.
Right.
And
Somebody
then-
did ask about the Living Futures ILFI and the Living Building Challenge. And one of the big differences between that kind of certification, a true zero net energy certification, is that it's not LEED is based on anticipated energy use and modeling, whereas ILFI and those certifications rely on actual results. And so you can't get certified until it's been operational for a full year. Yeah, challenging. Yeah, a thank you to Ventura for helping get us launching this series. Appreciate that. Any other questions or comments?
Yeah, or any lessons learned anyone wants to share? Any anecdotes for talking to real people, real clients? And they're, I love that. I like to know what people really, what they say.
Jennifer, right. A lot of
and
this is just
Andy.
being able to
And
provide
we got-
factual information to folks for sure.
Yeah, Andrew, go ahead.
Thanks. Recently, we're wrapping up a project in Ventura, a senior housing renovation project and retrofit that went through the process of, I think, 3C REN and getting energy credits through SOMA. They added variable refrigerant flow system to the entire building. They added air conditioning to 36 dwelling units, converted their hot water heating system to all electric and all electric heating, and removing those greenhouse gas burning appliances. They were wall heaters, 2 wall heaters in every unit. So, 72 wall heaters throughout the building that aren't burning, fossil fuels in the dwellings anymore. And I think they added solar and are going to get quite a few credits on their taxes back, but overall making a very, very much more energy efficient building. So we like how these new systems are helping with that, and we're living it right now. Our clients want these things.
Oh, that's good to hear. I love hearing that the clients, like, they're asking for it, because that's part of that's what we need to know, like all of us in the design construction business. If they're wanting it, the technology is there, and some of it is how do we help them know they want it or realize they want it, because it is of a benefit to them a lot of times. Yeah, especially on the old wall units, old fossil fuel or gas burning wall units, because a lot of them leak more than people realize. So it's just terrible indoor air quality. for folks.
We discovered a large fuel leak in that building. We don't know how long it had been going on. I will share that the electric ovens created a challenge in that they're trying to convert the whole structure to all electric, but the building infrastructure could not support the ovens, the electric ovens, and so the big draw, they would have to renovate the entire building's electrical system at great expense.
Wow, that's super interesting. And I mean, relatively, it has to be a balanced approach, right? So those induction cooktops are great. They have really good control, but yeah, they definitely take some electricity. So, and it's not, in terms of the impact, going after the heating, the building heating, space heating, and water heating is definitely going to be more impactful for the bottom line as well. So interesting. And is there a case study already written up on that?
No, we don't. We don't have one. RRM has we do some architectural, imagery after the project's done. This being renovation, we haven't done that yet, but would be interesting to see a few years from now what the metrics were.
Yeah, maybe we could talk about writing that up and tracking those numbers, because I think it helps potential clients go, okay, other people are doing it successfully, and here were their experiences.
Yeah.
All
Yeah,
right.
super interesting. I'm happy to hear it. Thanks for sharing that with us. And I don't know, maybe everyone on the call already knew about the project, but in case you didn't, it's nice to hear about it. Nice to know.
All right. I think that wraps us up. And if you have any feedback, you have our contact information, and we look forward to seeing you next time. Have a great holiday break, everyone.
Bye.
Thank you. Happy holidays, y'all.
Bye.
Thank you again. Bye.